Good morning students, welcome to physics class. In the previous class we have learnt about displacement, velocity, initial velocity, acceleration, final velocity and time taken. How do we relate all this? By means of equation. Now what is an equation? It is the process of equating one thing with another. Now, let us relate the displacement, velocity, acceleration and time of an object under motion. So, these equations are called the equations of motion. They are V is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U square plus 2AS. In today's class, we derive equations of motion by graphical method. Now consider an object is in motion with initial velocity u, attains a final velocity v in time t due to acceleration a, with displacement s. Now consider an object starting at the point D and reaches B. At the starting point, the initial velocity u. While reaching V, the final velocity will be v. So its velocity keeps increasing, and after time t, it reaches the point B on the graph. Now, the initial velocity of the object u, that is OD, is equal to u, which is equal to a. Now the final velocity of the object is v, that is OC is equal to v, which is equal to EB. Also from the graph we know that AB is equal to DC. So now let us derive the first equation of motion, that is V is equal to U plus AT, which relates the final velocity, initial velocity, acceleration and time taken. So from definition we know that acceleration is equal to change in velocity by time, that is final velocity minus initial velocity by time. So now what is the final velocity? That is OC. This is the final velocity minus OD. This is the initial velocity divided by the time taken, which is OE. So we know that OC minus OD is equal to DC divided by the time taken, OE. So A is equal to DC by T. Now DC is equal to AB, so which is equal to A into T. So from the graph we know that EB is equal to EA plus AB. So V is equal to U plus AT. That is EB is equal to final velocity V, then EA is equal to the initial velocity U, and AB is equal to AT. So we derive the first equation, V is equal to U plus AT. Now let us derive the second equation of motion. So from the graph, the distance covered by the object during the time t is given by the area of the quadrangle DOEB. So this is the quadrangle DOEB. So a quadrangle is the combination of area of a rectangle and area of a triangle. So the displacement S can be calculated from the area of the quadrangle DOEB, which is the area of the rectangle DOEA, this rectangle, plus the triangle DAB. Now area of a rectangle AE into OE plus area of a triangle half into AB into DA. So AE is U, OE is time taken T plus half into AB is AT, what we have derived already in the previous equation, and DA is equal to T. So S is equal to UT plus half AT square. Now let us derive the third equation of motion. So from the graph, the distance covered by the object during time t is given by the area of the quadrangle DOEB, which is equal to, here DOB is a trapezium. Then S is equal to area of a trapezium DOEB, which is the area of a trapezium. We know the formula for area of a trapezium is equal to half into sum of the length of the parallel side into distance between the parallel side. So here, what is the sum of the length of parallel side? That is OD plus BE, these two sides, into distance between the parallel side. The distance between the parallel side is OE. So S is equal to half into OD is U plus BE is V into OE is T. And we know that A is equal to V minus U by T, or T is equal to V minus U by A. Now therefore S is equal to half into V plus U into V minus U by A. That is for T, we are substituting the value V minus U by A. So after calculation, we get 2AS is equal to V square minus U square. So the third equation of motion is V square is equal to U square plus 2AS. Thank you, children.